How has lameness locator been validated? First, we determined what the precision or repeatability of the system was. If the lameness locator equipment was not repeatable, it would not have been worth pursuing further. Here are the results of a large retest validation experiment using 119 horses, where we collected data on live horses in one trial, waited about 5 minutes, and then collected another trial on the same horse. What we found was that lameness locator was precise. The test-retest interclass correlation coefficient for the lameness variables of lameness locator were all high, comparable to what would be seen and what has been reported for 6 strikes of the same limb on a force plate under controlled conditions. Also, the 95% confidence intervals for vertical head movement parameters that are indicative of lameness are very small, about plus or minus 6 millimeters, and those for vertical pelvic movement for hind limb lameness are even smaller, about plus or minus 3 millimeters. We then determined through experimentation that lameness locator is accurate for detection of lameness. Here are the results for horses with forelimb lameness of a head-to-head comparison with a stationary force plate. The correlation between the results of the inertial sensor system and the stationary force plate was significant and high. In this graph here, the x-axis is the force plate results and the y-axis is the inertial sensor results. But the correlation was very significant and high. Also, the 95% prediction interval of the inertial sensors for predicting what the results of a stationary force plate would be is only plus or minus 6% vertical ground reaction force in units of percent body weight. And as a comparison, changes in vertical ground reaction force in units of percent body weight using the stationary force plate of plus or minus 10% are considered indicative of mild lameness. So the 95% prediction interval is below that. Finally, we determined through experimentation that lameness locator is sensitive for detection of mild lameness, more sensitive at picking up mild lameness than a consensus of 3 experienced equine practitioners. Here are the results of a head-to-head comparison of the inertial sensor results with subjective evaluation by 3 experienced equine practitioners. We determined which was first to pick up an induced lameness using a sole pressure model. We randomly picked the limb in which to induce lameness. The evaluators were blinded to the limb with the induced lameness and to each other's evaluation results. The horses with induced lameness were simultaneously evaluated by the inertial sensor system and by the 3 evaluators. Sole pressure was introduced and then gradually increased until the inertial sensors picked up the correct lameness and the evaluators picked up the correct lameness. And here are the results. For forelimb lameness, lameness locator, or the inertial sensors, picked the correct limb first before the consensus of the evaluators in 63% of the trials. The evaluators picked the correct lameness first in 3% of the trials, and it was a tie where both the inertial sensors and evaluators picked the correct limb at the same time in about 1/3 of the trials. For hind limb lameness, the results were even more telling. Lameness locator picked the correct limb first before the evaluators in 80% of the trials. The evaluators picked the correct limb first in 13% of the trials, and it was a tie in about 7% of the trials.